Assalamualaikum warahmatullahi wabarakatuh, and hi to our lecturer and fellow friends. So today our group will present about the monthly temperature and total rainfall statistic from May 2021 to December 2022 in Malaysia. So my name is Nik Nadia Farhana binti Nik Muhammad Hilmi, and my partner is Nik Hasmaniza binti Nik Ramli. First, we're gonna look at introduction. Weather conditions strongly affect daily life, economic activities and environmental sustainability. Among meteorological elements, temperature and total rainfall are key variables shaping climate patterns. Understanding their relationship is vital for forecasting, agriculture, water management and environmental studies. This project examines the link between monthly average temperature and monthly total rainfall in Malaysia using data from MALAYSIA from May 2021 to December 2022. Numerical analysis is applied through the least square approximation method, testing both a linear model and a quadratic model. Accuracy is measured using the sum of square error SSE, with the model showing the lowest SSE chosen as the best fit. The findings of the study may provide useful insights into rainfall patterns under different temperature conditions and contribute to a better understanding of Malaysia's climate characteristics. So, the objectives of our presentation is to determine the best fitting mathematical model using the least square approximation method, and next to compare the sum square error of linear function and quadratic function. And lastly, our objectives is to identify the most accurate model to represent the relationship between temperature and total rainfall. So here is the 20 data that is used in this case study, consists of monthly temperature and total rainfall statistic for Kota Baru, Kelantan in Malaysia, cover the period from May 2021 to December 2022. The data were obtained from the Malaysian Open Data Community. I will explain about the least square linear function that was obtained from our data analysis. To determine the regression coefficient, we first construct the normal equation in matrix form, which is 2 by 2 matrix. So the general matrix equation is n summation of x squared, summation of y, and summation of xy. By using the values calculated from our dataset, the equation becomes as follows: n equal to 20, summation of x equal to 544.3, summation of x squared equal to 14,825.07, and summation of y equal to 627.795, and lastly the summation of xy equal to 16,730.867. By solving the system of equations, we obtain the regression coefficient. The regression coefficient that we obtain are A0 is 877.9331654, and A1 equal to negative 31.10576577. These coefficients have specific meanings. First, A0 is known as the intercept. The intercept represents the predicted value of y when x equals to 0. Therefore, if x is 0, the predicted y value is approximately 877.933. Next, A1 is the slope of the regression line. The slope indicates the rate of change of y with respect to x. For every increase of 1 unit in x, y decreased by negative 31.1058 units. Since A1 less than 0, y decrease, and downward trend happen. So, the resulting linear equation that we obtain is fx equal to A0 plus A1x. Fx equal to 877.9332 minus 31.1058x. By using the Excel, we substitute the linear equation that we obtained just now. We substitute the equation with original x, and we got the new linear equation for 20 data. Overall, the linear model indicates a negative relationship between monthly temperature and total rainfall in Kota Baru, Kelantan. As temperature increase, rainfall generally decrease. However, the data points are widely scattered around the trend line, indicate that the linear model does not fully capture the behavior of the dataset. This is supported by the relatively high summation of square error (SSE) equal to 8,629.321,663, suggests that the linear model is less accurate in represent the relationship between temperature and total rainfall. We would like to calculate the sum of square error of least square linear by using the formula SSE equal to, in bracket, observed fx minus calculated fx, close bracket, square. By using the SL, we will get the observed fx, calculated fx. Calculated fx is the linear equation that we found just now, and the error square we got is, and the sum of square of error SSE equal to 8,629.321,663.
Okay, so next we're going to discuss for 3.2, which is about least square quadratic function. For this quadratic function, first of all, we use Excel to calculate the sum of x square, x to the power of 3, x to the power of 4, x square y, and xy. After we got the total, we substitute into the normal equation 3 by 3 matrix form, and then we substitute the value of n, the sum of x squared, sum of x cubed, and sum of x to the power of 4, and also the sum of y, sum of xy, and sum of x squared y into the normal equation of 3 by 3 matrix form. After that, we solve for the value of a0, a1, and a2. We got the value of a0, which is 17795.07631, and the value of a1, which is negative 1284.528.602, and lastly the value of a2, which is 23.19686721. So where we got the resulting quadratic equation. So in the quadratic equation, there is the constant like a0, a1, and a2. A0, the constant term, which is give the mean of intercept. It's give the value of y equal to 17795.07631 when x equal to 0. A1 means for the linear coefficient. It is influences the initial direction and trend of the graph, whether it is increasing or decreasing. So for our calculation, we got an A in a negative value. Large negative value means the curve initially slopes downward as x increases. A2 means the quadratic coefficient, which is it determines the curvature or shape of the graph. Since it is a positive value, the parabola is open upward. The larger the value, the sharper the upward bend. Okay, next we go for the graph for the quadratic function. Okay, for the graph, so before we proceed to the plotting the graph, we will calculate the new value of fx using the quadratic equation that we got previously. So as we can see from the graph, overall the total rainfall shows a decreasing trend as temperature increases. Based on the quadratic model, y equal to 23.1969 x squared minus 1284.5286x plus 17795.0607663. Rainfall decreases rapidly at lower temperatures and reaches a minimum value at approximately 27.7 degrees Celsius before increasing slightly at higher temperatures. They suggest a non-linear relationship between temperature and rainfall. Compared to the linear model, the quadratic function appears to fit the observed pattern more closely because it captures the curvature present in the data. However, this quadratic model offers a better fit than a standard linear model because it gives a smaller value of sum of squares error, which is SSE value equal to 8629.321663, suggesting that the quadratic model is more accurate in representing the relationship between temperature and rainfall. Okay, so now we're going to calculate the sum square error for the quadratic function using the formula the square of observed fx minus calculated fx, and then we're going to sum all the value of error square. Then we got the value of 4016.125912. Okay, so we're gonna do the comparison, the value of SSE between the linear model and quadratic model to make a conclusion or decision. So the quadratic model produced an SSE value of 4016.125912, which is significantly lower than the SSE value of 8629.321663 that obtained from the linear model. Since a low SSE indicates more accurate fit to the observed data, the quadratic model is considered the most suitable model for describing the relationship between monthly average temperature and total rainfall in Kota Baru, Kelantan. Therefore, the quadratic model was selected as the best fitting model and can be used to estimate rainfall values based on the temperature within the range of the observed data. So the conclusion that we can make from this discussion, the project successfully achieved its objective of analyzing the relationship between monthly average temperature and total rainfall in Kota Baru using the least square approximation method. Regression models were developed and compared to identify the best mathematical representation of the data. The second order quadratic function provide a better fit than linear function. The quadratic models was more effective in capturing the non-linear relationship between temperature and rainfall. The best fitting quadratic regression equation is the quadratic model achieve a lower sum of squares error, which is SSE equal to 4016.125612, and the linear model SSE value is 8629.321663. A lower SSE, which indicates that the quadratic model provides a more accurate representations of the observed data. The results suggest that the relationship between temperature and rainfall is non-linear. And rainfall variation cannot be explained by temperature alone. There is many other factors may influence rainfall, including humidity, monsoon activity, wind patterns, atmospheric pressures. The study demonstrates that the importance of selecting an appropriate mathematical model for environmental data analysis. So, quadratic regression is a useful tool for modeling complex relationships between meteorological variables.